This lesson is find the determinant of a 4x4 matrix using co-expansion method. This is a 4x4 because I have 4 rows and 4 columns. However, if we use the cofactor expansion, it is very lengthy. Okay, so anything above 3x3 is going to be very lengthy if I use cofactor expansion. Okay, one more time. If I am using cofactor expansion in a 4x4, 5x5, 6x6, 7x7, the method is too lengthy. So we're just going to skip that. However, I'm going to give you the answer. The determinant is -4. Okay, and we will show you how it becomes -4. Okay, now let's do basket weaving on a 4x4. So first column, put it on the right side. Second column, put it on the right side. Third column, we put it on the right side. The only column that you do not move is the last column. Okay, you can use row column 1, column 2, column 3, put it on the right side. So if you remember a 3x3, I only take column 1, column 2 and put it on the right side, and the last column stays. Okay, so 4x4, 5x5, same thing. Only the last column stay. All the other columns bring it to the right side. Okay, so I brought column 1 here, column 2 here, column 3 here. Now let's do basket weaving for that. So starting from the left side, 1 times 9 times 1 times 3, 27. 3 times 5 times 1 times 0, 0. 1 times 15 times 0 times 4, 0. 4 times 3 times 2 times 2 gives me 48. Why are there 4? Because we are in a 4x4. Okay, so 1 times 9 times 1 times 3, 27. 3 times 5 times 1 times 0 gives me this 0. 1 times 15 times 0 times 4 gives me this 0. And then 4 times 3 times 2 times 2 gives me 48. Okay, don't forget the minus. The minus is always there. Now we did the left. Now reverse it. Go to the right side. 0 times 2 times 5 times 4 is this 0. 4 times 1 times 15 times 1 is this 60. 2 times 1 times 3 times 9 will gives me this 18. And then 3 times 0 times 9 times 1 gives me this 0. After that, simplify a little bit more. 27 plus 48 will gives me this 75. 60 plus 18 gives me this 78. Don't forget the minus. So now it becomes 75 minus 78, which come out to be -3. But our determinant is -4. So it doesn't work on a 4x4. So be very careful. Basket weaving only work for 3x3. Anything bigger than 3x3 will not work. Okay, so 4x4, 5x5, 6x6, 7x7, basket weaving doesn't work. It only works for 3x3. As you can see, here's a 4x4. The determinant came out to be -3, but the answer is -4. So again, be very careful. Okay, I'm going to go back to the beginning. Cofactor expansion takes too long if it's a 4x4, 5x5, 6x6, and so on. So we're going to skip that. Okay, basket weaving only work for 3x3. So the best method will be row operation. Row operation will work for 3x3, 4x4, 5x5, and so on. Okay, so row operations will be the best method to find the determinant for 3x3, 4x4, 5x5, 6x6, and so on. Okay, so here's the original problem. Now in this situations, I'm going to leave row 1 and row 3 as is, and I will show that a little bit later. Okay, so row 1, row 2, we'll leave it alone for now. we're going to make this 4 become a 0. We're going to make this 4 become a 0. So the opposite of that, we're going to do negative 2. So negative 2 times row 3 plus row 4. Okay, so why negative 2? So that when I multiply this 2, I will get that 4. And since it's a negative, I subtract, gives me this 0. Okay, so negative 2 times 2 gives me 4. Negative 4, one more time. Negative 2 times 2 gives me negative 4. Negative 4 plus 4 gives me 0. One more time. Negative 2 times 2 gives me negative 4. Negative 4 plus 4 gives me this 0. Negative 2 times 1 gives me negative 2. Negative 2 plus 2 gives me this 0. Negative 2 times 1 gives me negative 2. Negative 2 plus 3 gives me this positive 1. Okay? Now, if you look very carefully, there's a reason why I leave the second row alone. So now I'm going to switch row 2 and row 3. So now it comes down here. So I'm going to switch row 2 and row 3. So here's row 2, here's row 3. I'm going to switch these two rows. So row 2 now becomes row 3. Row 2 now becomes row 3. Row 3 now become row 2. And there's a reason why I left that alone in the beginning. So now row 3 becomes row 2. And as you can see, I need this to be a 0 and this right here, so it could stay in that diagonal pattern. Okay, because I need that right here so that when I multiply the diagonal, there's a number instead of a 0. Okay, so this is a 0 already, so I don't have to worry about it. This is a 0, so I don't have to worry about it. Leave it alone. Now I just need to take care of this row so that I can have 0, 0. Okay, so I'm going to do this. So negative 3. To get this 3 to become a 0, I need to multiply negative 3. And that's where the 0 comes from. So negative 3 times 1 is negative 3. Negative 3 plus 3 gives me this 0. Negative 3 times 3 is negative 9. Negative 9 plus 9 gives me this 0. Negative 3 times 1 will be negative 3. Negative 3 plus 5 gives me this 2. Negative 3 times 4 gives me negative 12. Negative 12 plus 15, okay, will gives me this positive 3. Okay, so one more time. Negative 3 times 1 is negative 3. Negative 3 plus 3 gives me the 0. Negative 3 times 3 gives me negative 9. Negative 9 plus 9 gives me 0. Negative 3 times 1 gives me negative 3. Negative 3 plus 5 is this 2. Negative 3 times 4 gives me this negative 12. Negative 12 plus 15 gives me this positive 3. Okay, and if you look very carefully, there's a 0 here, there's a 0 here, there's a 0, 0, 0, 0. So this part right here, when it is 0, then we are completely done. We don't need to solve anymore. And as you can see, this looks like the upper triangle from LU factorizations. Okay, so 0, 0, 0, 0, 0, 0. So we are done. We ignored that part. Now we just multiply the diagonal only. Just multiply the diagonal. So 1 times 2 times 2 times 1 gives me 4. Okay, however, in the beginning I did switch the rows. Remember the rule, if I switch the rows, I need to put another negative in. So now it becomes negative 4. Okay, so be very careful. One more time. When you switch rows or columns, don't forget to put another negative in. When you do row operations, to find the determinant in row operations, our objective is to have the bottom corner here, the bottom triangle right here, the bottom triangle 0, so that when all I have left is just this diagonal, and then multiply the diagonal. Okay, so one more time. when we are looking for the determinant in row operations, we want the bottom part right here where I am circling. That area needs to be a 0. So this little bottom triangle area right here needs to be 0. After that, I just multiply the diagonal. Okay, so that gives me 4. However, I switched the row, so therefore I need another negative. So the determinant is -4. And as you can see from the top, I did not use cofactor expansion because it's very lengthy. So I gave out the answer, which is -4. Basket weaving does not work anything bigger than 3 by 3. So 4 by 4, 5 by 5, 6 by 6, so on, does not work. Only work for 3 by 3. Row operations. In row operations will be the best method, and it will come out the same solutions. Okay.